Okay, so this is the Sterno lab. I'm going to be giving you a little bit of hints going forward, but obviously you need to do this by yourself. So pre-lab questions we should have done together. It says, write the balanced equation for the reaction of calcium carbonate and acetic acid. So calcium, Ca, check your periodic table, +2. Carbonate, check table E, that's going to be CO3 -2. I want to make sure. I'm just assuming. I just assumed I know, but yes. Okay, so notice how those oxidation states cancel out, +2 and -2. So no need for crisscrossing anything, CaCO3. Calcium carbonate is a solid. That's the chalk. And acetic acid. Now, if you go to reference table K, acid table, there are two formulas for acids. So let me show you. This is acetic acid, and there are two forms. So we're going to use this form. This form here at the top is when we use organic chemistry. This bottom formula is what we're going to use because it shows an H+, and then it shows this acetate ion, which is negative. So that's the formula we're going to use. And so let me go back to this. So HC2H3O2, and that is an acid. Okay, now, so we need to look for which of the reaction types is this. So I know it's not going to be synthesis because that would be one simple thing coming together. I'm sorry. Two simple things coming together. I know it's not decomposition because that's one thing breaking down. I know it's not a single replacement because there's no singletons here. We have two compounds. So it is a double replacement. We have two compounds. So that's my answer to this one. Now, in terms of finishing it out, calcium, we remember that was our +2. This is the positive. And the H was positive. And then carbonate was negative, and acetate is negative. So you're going to switch those around. And I'm not going to tell you the answer. You can do that. So put the new negative partner with calcium over here, and put the new negative partner with hydrogen right here. And then, of course, once you do that, crisscross your individual charges, and then you perhaps need coefficients. So we'll see. Now, number 3, what is the chemical formula for ethanol? How about I draw it? So I'm going to draw it for you. Oh, silly me. Okay, so those are H's, hard to tell. So chemical formula for ethanol is C, 3 H's, C, 2 H's, OH, ethanol. So this is what we call a structural formula. If you wanted to group them together, you could say C2H5OH. And that is interesting. Notice I didn't group this H with these H's. That's because hydroxide is a polyatomic ion. It's an acid group here. Sorry, not acid group, an alcohol group here. So I'll have gone over that with you in class. Okay, so this is the lab. You should have, if you did it, you would observe right here. If you didn't do it, you're watching the video. Okay, so here are the questions. Define filtrate. No, you look it up. And think about what we did in the lab. And if you didn't do the lab, you watch the video. List 2 to 3 observations of the filtrate. So if you were in the lab, again, you see it. If you weren't in the lab, check a look at that video again. If you really weren't able to see, then just explain that. Write the chemical names, not formulas, for the two products of this reaction. So going back to this right here, those are your two products, and you're going to write the names. So look on the front, and I'm just going to give you a hint. It probably, because we follow the law of conservation of mass, it's probably going to contain the same kinds of stuff we had before. So things like calciums, it's going to be in there. Acetates is going to be in there. What else is going to be in there? Carbonates are going to be in there. And then maybe a hydrogen is in there. So you have to figure out, how do these go together? So look on the front. Okay, write the chemical formulas for each substance in the following reaction and balance. Aluminum bromide and chlorine yield aluminum chloride and bromine. Okay, aluminum, charge, found on periodic table. Bromide, charge, found on periodic table. Okay, that does not cancel out. I'm sorry, yeah, it does not cancel out, so we crisscross, we get that. Clean up our charges now, because now it's neutral. And chlorine, okay, chlorine is diatomic by itself. Yields means arrow. Aluminum chloride, we know from before it's Al plus 3, Cl. Now it's in a compound, so it's minus 1. So that doesn't cancel out. So let's crisscross and then clean those up. And then bromine now is all by itself, so it's a diatomic. So I gave you that much. I'm asking you now to balance it. Okay, so this is the kind of the basis. You need to balance it for coefficients. You can go ahead and do that. Predict the products of this reaction and then write a balanced chemical reaction using proper formulas. Okay, so zinc, not in a compound, so no charge. Lead, Roman numeral 2, nitrate. So lead is this. It says plus 2, so that's it. Nitrate. Check our table E. Okay, so that is not neutral, so let's crisscross them down. Okay. All right, so I see a singleton and a compound. So that can't be decomposition. That can't be a synthesis because this was too complicated. Can't be double replacement because that is a singleton. So this is a single replacement. Okay, so with single replacements, you need to check table J to see, is zinc more active than lead? So I'm going to look there. We can look there together. Table J. So here's zinc and here's lead. So zinc is higher on table J, which means it is able to replace. So lead is bumped out. And then the zinc is with the nitrate. But before you get ahead of yourself, don't forget zinc is now in a compound, which means it has a charge. Nitrate has a -1 charge. Okay, so that's not neutral, so we got to crisscross and do that. Now, it said balanced, so I'm going to ask you, please check your coefficients, do your scorecard if you need to. Nitrogen gas is combined with hydrogen gas to form aqueous ammonia, NH3. Write the balanced reaction, including phases. So N, nitrogen, 2. Hydrogen is diatomic, 2. I said NH3. Okay, and it did say phases, so gas, aqueous. Okay, I'll give you that much. It is not balanced. It is not balanced. You need to find coefficients, okay? Then in part B, it says if 83.5 liters of ammonia are formed, how many moles of nitrogen are required? Round to the proper of Sig Figs, use your expanded mole map. So if you go to your expanded mole map, which I don't have able to be pulled up for you, you're going to need to go from liters of one thing to moles of another. So if you look on your expanded mole map, there are 2 ways you can do it. You can go from liters of one thing divided by 22.4 to give you moles, and then you can multiply by the conversion factor to get moles of your second thing. Or you can get liters of your first thing, multiply it by your conversion factor to get liters of your second thing, and then you can divide by 22.4 to get moles. So it's up to you. There are either way you can do it, but I highly recommend you have to use your mole map. I mean, even I would, most likely. Now, it talks about Sig Figs. You take your Sig Figs from your given, so this right here, that is 3 Sig Figs. So 3 Sig Figs should be in your final answer, and your final unit should be moles. And that's all I'm going to tell you on that. You can do this. But remember, you have to use your conversion factor. Your conversion factor is the coefficient of what you seek over the coefficient of what you know. And so you're going to be using this reaction, with that has to be balanced, by the way. So you'd need to figure out what are the coefficients of this, and then you can use that to find your conversion factor down here. So again, I didn't want to give everything away, but just want to give you a little bit of a heads up. So with that, that's all I'm going to have for you now. If you still have questions, please reach out. Please find me. Otherwise, good luck. Thanks.